okay? So I want you guys to start thinking about those. I want you guys to think in your head because this is going to be on the test on Friday. And I know a lot of you feel like you're not prepared. If you think 1, a plus or a minus sign, a squared term, probably a Pythagorean identity, start watching those identities and seeing them. Now all I have to do is take the square root of this guy and I get this one right here. So if I had taken the square root of the first term, so I have to take the square root of the second term, guess what? The square just goes away. Another Pythagorean identity. Mikey, turn around, please. Thank you. So, 4x. Make sure you have the same number if you're using a Pythagorean identity. If you're using your half angle or your double angle identities, make sure that what's inside your parentheses is different. But because we're using Pythagorean identities, they stay the same. Number 3, tangent squared of theta plus 1. Probably a what? Pythagorean identity. Secant squared of theta times cosine squared of theta. And we know we should please be writing this one down, that cosine of theta times secant of theta is 1. Have that one in your journal. That's a good one to have. Right here I rewrote if. When you see these fill in the blanks, the first thing you should think of is go to my identities. They're probably going to be pretty self-explanatory. These aren't verifying. These aren't changing too much form. These ones are they're just very, what's the word I'm looking for? They should be like, easy, I guess not easy, but like fast. Fast is the word I'm looking for. They're not going to take you that long to do. The fill in the blanks are identities. Think identities. So I changed this one to a sine and a cosine. My sines cancel. I change my secant to a cosine. My cosines cancel. I'm left with 1. Write this one in your journal, please. Number 5, please write in your journal. I see this and I think, what identity am I using? What identity do you think I should use if I have 2 things multiplied together and then 2 things multiplied together and they're both sine and cosine and there's an addition or a subtraction sign in them? What identity are we using? Exactly, Nathan, sum and difference. So which one is it? Sine, cosine? Cosine of A, which is 40, plus B, which is 50. Cosine of 90 degrees. What's cosine of 90 degrees? 0. Yep. If there are numbers, so the question was, will we get it wrong if we put cosine of 90? If there are numbers, I don't want to see any cosines or sines. Like right here, I have a 40 degrees and a 50 degrees. You can find those. If there are variables, like theta or x, will probably be the variables I will use. I want to see identities being used. So right here, I have an identity that I used, and I found that it was cosine of theta. I will still see cosines and sines, and maybe some numbers, but if there are numbers inside your parentheses, I have to see numbers. So right here, 2 times the tangent of pi over 3 divided by 1 minus the tangent squared of pi over 3. Well, that's 2 times, what's the tangent of pi over 3? Or how would I go about finding the tangent of pi over 3? Your chart, exactly. Use your charts if you need them. Tangent of pi over 3 is root 3. Divided by 1 minus root 3 squared. You will come up with root 3. Negative. Right here, I think, if ever I see a 2 multiplied by something, if ever I see a 2 in my answer, you know what my automatic thought is? Double angle identities. So I go look up my double angle identity, and I find that 2 sine of pi over 12, cosine pi over 12 is going to be sine of 2 times whatever is in here, pi over 12. I do some division, and I get pi over 6 as my answer. I see a cosine squared minus a sine squared, and my first thought is Pythagorean identities. So I go look up in there, and I see, well, that has a plus sign. Be very careful, guys. You could get confused. That has a plus sign. It doesn't have a minus sign. So I go look at my double angle identities, and I find it's cosine of 10x. Yeah, you just use your sine of a minus b, so that's sine of pi over 2 times cosine of theta minus cosine of pi over 2 times sine of theta. Because what I did, Heidi, is I had my components right here. Here's A and here's B. How do you know what theta is? You don't. Theta is a variable. So we say, what's sine of pi over 2? Well, that's 1 times cosine of theta minus cosine of pi over 2 is 0 times sine of theta. So my answer is just cosine of theta. Sorry, I have to move on because I really want you guys to be able to. That's fine. Try to simplify in the next one. Number 12 is a good test question. Tangent of 22.5. If I see a 0.5, I automatically think half angle formulas. So I use my half angle formulas. It says tangent of 45 divided by 2. Tangent of 22.5 is equal to tangent of 45 divided by 2. Now, I use the 1 minus cosine of 45 to try to find it. Keep it in exact form. My answer should be the square root of 2 minus 2 all over 2. Next one, I say, my first step, I said, well, the cosine of 7.5 is the same thing as the cosine of 15 divided by 2. Well, I don't know cosine of 15, so I better try to find it. So I went over here and I said, well, the cosine of 15 is the same as the cosine of 30 divided by 2. So I use my half angle formula, which says take the square root of 1/2 times 1 plus cosine of 30. I looked up my cosine of 30 and I found that it was the square root of 3 over 2. I added 1 plus the square root of 3 over 2, and I multiplied both of them by 2, or the bottoms by 2, and I got the square root of 2 plus the square root of 3 all over 2. So that equals, guys, what I just did was I found cosine of 15. Do you guys see that? That's what I did? I found the cosine of 15. Does that make sense to you guys? No, it doesn't make sense. Why not, Nathan? I said that the cosine of 7.5 equals the cosine of 15 over 2. But I don't know the cosine of 15, so I made a separate problem over here. It said the cosine of 15 is the same as the cosine of 30 over 2, because I know 30. Then what I said is I used my half angle formulas, and I came up with the cosine of 15 is equal to this right here. So now when I go back, I'm going to say the cosine of 15 over 2 means the square root of 1/2 times 1 plus cosine of 15. But I found the cosine of 15 over here. So the cosine of 15 is the square root of 2 plus the square root of 3 over 2. Does that make sense? So then I plug that in right here, Nathan, for my cosine of 15. And I start adding things up, and I get this answer. Well, I'm adding what? Yeah, it does actually, because we always make it, we take the same denominator. So it would be plus 2 over 2, right? So you get 2 plus the square root of 2 plus the square root of 3 over 2. This next one, people in the morning class said that they understood these ones. Are these ones okay for you guys, these triangle ones? Yeah. If you're having trouble, you need to let me know. And if I need to explain something. So let's just check our answers. So for number 13, your answer is negative 6 minus 4 square roots of 5 over 15. For 14, it's 24 over 25. 15 is 3 square roots of 10 over 10. And 16 is 24 over 7. Does anybody want me to go over 13 through 16? Any of these problems? 13? 15? This is 15? Okay, so it's a half angle, right? Because it's divided by 2. So you guys, half angle means divided by 2. This tells me what triangle to go to. Go to X. Here's my X triangle. My half angle formula tells me that it's the square root of 1/2 times 1 plus cosine of X. So I go up and find cosine of X. So I go up to my triangle. Cosine is adjacent over hypotenuse. So 4 over 5. So I write that in right there. Then I say, what's 1 plus 4 over 5? Does that make sense, Nathan? Okay, so now I have 1/2 times 9 over 5. So this is not what I have right here. So I have 1 times 9, which gives me 9, right? 2 times 5, which gives me 10. So that's how I got these. What's the square root of 9? 3. Then I have to rationalize my denominator. So that, okay? So our 13 through 16. I know somebody said, is there any other problem you want me to go over? Can I go over, should I go over one of either 14 or 16? 16. The double angle tells me, 1, that it's 2 times the tangent of x divided by 1 minus the tangent squared of x, which just means find the tangent of x and square it. So I go up to x because it tells me to use x. And I go and I find the tangent, which is opposite 3 over adjacent 4. That tells me that that's 2 times 3 over 4 divided by 1 minus 3 over 4 squared. Matt, you watching? So, when I multiply this out, I get 6 over 4 divided by 1 minus 9 over 16. 1 minus 9 over 16 is the same as 7 over 16. And 6 over 4 is the same as 3/2. Then I have to do copy dot flip. Listen to me carefully because a lot of people have asked me what copy dot flip means and how to use it. Copy the top, the numerator. Right here. In this problem, 3/2 is our numerator. Dot, put a multiplication sign. So I copied, I put 3/2, dot, and then take the bottom and flip it. So I flipped it to get 16 over 7. That's copy dot flip. So let's move on. Let's verify each identity. This is wrong, wrong, wrong. Wait, that's right. The next step's wrong. So We start off and we say cosecant squared of x minus 1 over cosine of x. I'm going to start on that side because it's the harder side and I don't know where to go if I have the other one. So what I do is I say, well, what identity should I use up here? What type of identity do I use up here? Pythagorean identities. We're using our Pythagorean identities. So I know that that's the same thing as cotangent squared divided by cosine. And I rewrite that as cotangent squared divided by 1, or times 1 over cosine of x. Look at this, guys. I see a cotangent, and I see a cotangent squared, so I'm just going to take one of my cotangent x's and leave them. And the other, for the other multiplication of the cotangent x, I'm going to change it to cosine of x over sine of x. And I still have that times 1 over cosine of x. Right? I cancel my cosines because I've got one on the top and one on the bottom. So now I'm left with cotangent of x times 1 over sine of x, and using my reciprocal identity, I will have cotangent of x times cosecant of x. Huh? Is 1 over sine. Okay, here's a big, huge hint. Everybody open their ears, please. Or watch the screen. 2a and a. Can I do anything with that? If I see angles that aren't the same, use your identities. Big hint for the test. Cosine of a, sine of 2a. Change this using my double angle formula. So, yep, I just plug in my double angle formula for my sine of 2a. So, did everybody see what I just did? And everybody look up there and see, because I see some of you guys not paying attention and not writing things down. And I just want to make sure that you guys do well on this test, because I don't want to hear any complaining. Huh?
Let's use identity.
I just use my identity. Sine of 2a is 2 sine of a times cosine of a. I want to get all my angles to be the same. You see I have an a and a 2a? A. No, but we're not talking about Canada right now. Why did I pull out a cosine right here? Because of my identity of sine of 2a. Sine of 2a equals 2 sine a cosine a. Does that make sense? Okay. So now I say that 2 goes out in front. Cosine of a times cosine of a is cosine squared of a. And sine of a right here. Well, I know, yes. Cosine of 2a? How about what? Cosine of 2a? Then you would use the identity for the cosine of 2a. No, there's 3 of them. I see what you're asking me. Because there's 3 of them. Try different ones. You might have to try a few of them. So you're what? You're multiplying them all together, not adding them all together. You're multiplying them together, not adding. Cosine times cosine is cosine squared of a. So, I use my Pythagorean identity to get from here to here, because I see in my answer I don't have any cosines. I want to get rid of them. I know that cosine squared of a equals 1 minus sine squared of a. That's still multiplied by 2, so I distribute my 2. Or actually I distribute my And then I distribute my sign, because I have to distribute both of them. So I get 2 sine of A minus 2 sine cubed of A as my answer. Solving the equation over the indicated domain. Make sure you know which domain you're using. Number 19, I solve for sine because it tells me in my process for 7 and 8 in journals, 7 and 8, excuse me, if there's one trig function, solve. Isolate it. So I take sine squared of x equals 3/4. I get that by isolating it. Then I square root both sides, and I get that sine of x equals plus or minus the square root of 3 divided by 2. I look it up in my table, and I find that that happens at 60 degrees and 120 degrees. Yes?
Can you go back to the...
Nope. You can go check it out online. I just have to get through these. Yep. What do you mean the negatives? I only did root 3 over 2. So I need to do the negatives, right? So 60, 120, so 240, and 300, right? Okay, I see a 2x, I see an x. What do I need to use? What did I tell you guys to look up at the board for? Identity to get what? My angle's what? Why am I doing this? What am I trying to do? Why do I need to do this? You have to use the double angle identity, right, so that you can get your angles to be the same. So I use my double angle identity, which says 2 sine of x times cosine of x equals cosine of x. I subtract cosine over. I factor out cosine. And I set both of my factors equal to 0. Cosine of x equals 0 or sine equals, and I solve. I divide by 2, so sine x equals 1/2. I look it up in my tables, and those are the answers I should get. This is over a restricted domain. These two. Got like 5 minutes, guys. 5 more minutes. Less than 5 minutes to get through these ones. Want to have time for you to get to your test. So, what I did for this one is I brought the 1 over. I saw that one was a squared term and one wasn't a squared term. One was just a linear term. Therefore, I use my factoring trinomials. Do you remember doing that? We've done it before. We did it in Algebra 2. You'll do it the rest of your life in math. So I get 3 times cosine x plus 1 and 2 times cosine x plus 1 equals 0. I set both of them equal to 0, and I solve. Cosine of x equals negative 1/3, or cosine of x equals negative 1/2. Remember, I'm just setting each part equal to 0 and solving. I subtract 1, divide by 3. Now, because it's in degrees, and negative 1/3 is not in my table, I go put my mode on degrees, and I take the arc cosine of negative 1/3. To find that, I get 109.47 and 250.53. This is over all degrees, not just between 0 and 360, so I must add plus or minus pi k. Negative 1/2 is in my tables, and it comes out at 120 and 240 plus or minus 360 k. I got it all on one side. Used because I don't have Pythagorean identity. Again, I'm going to have to factor these. Rules are not going away. Copying these down blankly. Make sure you understand what you're doing copying these down. Make sure you understand where things come from. Because it doesn't help to just write it down. It's not going to help you in your journal if you just copy some stuff down. You can make rules. They don't have to come from stuff that I've done. So, coming and give you a problem to solve. Factor these. I get cosine equals 1/2 and cosine equals -1. I look in my table, I find that happens at pi over 3, 5 pi over 3, and pi. Plus or minus 2 pi k. And it's unrestricted, guys. You write the plus or minus 2 pi k or 360k when it's unrestricted. Can you push this chair in, Mikey? These ones we're doing graphically. We go, and what I do when I solve them graphically is I say x times sine of x minus cosine of x. I set them equal to 0. I put them in my calculator. I locate those zeros. So right here I located one. It's located my 0, located my 0, located my 0. Set the whole thing equal to 0, put this in y equals, Matt. And then you're going to look for the zeros. What you have to find individually. You're going to have to look for this 0, look for this 0, look for this 0. Huh? It's not in degrees because it says 0 to 2 pi. Check your mode. If your mode is supposed to be in degrees, make sure that your y equals has degrees in it. I mean that your mode is in degrees. Make sure that when you plug in your calculator, you're in radians or degrees, depending on what you need. Right here, I'm in radians. This is already set equal to 0, so I just put in my calculator, I find the two zeros, and I solve. Those are my answers. Please take the total out of 48, and let's make a bend stack. Please, yes. Huh? Secant is this on. Okay. Guys, what? Julia? Cosecant? Because cotangent times tangent is 1. And 1 times cosecant theta is cosecant theta. We also have this, sine squared theta times 1 cotangent squared theta plus 1. Pythagorean identity. We get cosecant squared theta. Yay, fun, go us. I would write number 5 down in your journal. Number 6 should be the same as your homework, that sine of pi over 2 minus theta, and should be cosine of theta. I did this one just a few minutes ago on the homework.
So it's just cosine theta.
Yep. 7, I look and I see that. And Ashley said, well, that's the sine of A minus B to me. And she said, but do I need to go further? And I said, yes. What's A? And she said, 40. So I said, so that's sine of 40 minus 10, which is the sine of 30 degrees. What's the sine of 30 degrees? 1/2. Yes. Boom. Number 2? Number 2. Okay, so for number 2, I said I'm gonna factor out a 4 out of my equation. Then what I'm going to do is I'm going to say, well, that's the same thing as the square root of 4 times the square root of 1 minus sine squared of 2x. The square root of 4 is just 2, and the square root of 1 minus sine squared of 2x is cosine of 2x. Eight. Tangent of pi over 4 is 1. So I say that's 2 times 1 divided by 1 minus 1 squared. 1 squared is 1. 1 minus 1 is 0. So that's equal to 2 over 0. Oops, can't have that. Undefined. I look at this one. This is the easiest one for me to put on the test. You guys have seen it a lot. I know.
Which one?
9.
Oh,
Something similar. Remember that this is twice this. I could put number 10 on the test, and I don't know how many of you guys would put 5 as my answer. But remember, that's your Pythagorean identity, and the answer, as long as 5x and 5x are the same, which they are, the answer is 1. Moving on. In this one, I do the secant of 22.5 is equal to 1 over cosine of 45 over 2. Wow, I really don't have a lot of time. Then I tried, and I said that I found the cosine of 45 over 2 using that half angle identity. When I got my answer, I said, well, that's not my answer because I'm not looking for cosine, I'm looking for secant. Secant is 1 over cosine. So I took 1 over root 2 plus root 2 over 2. I multiplied both sides. So I copy that flip. When you have the square root of a square root, you do not have to rationalize the denominator. Yay for us. We better be praying for a square root of a square root, right?
Wait, so this is for number
Question.
1?
Yes.
What is so answer?
So the answer is.
Okay, I was like, so answer. I was like, what's the difference between answer and so answer?
It's so the answer.
So the answer is.
So the answer is. Okay. Cosine, of 75 is the cosine of 45 plus the cosine of 30. So I used my sum and difference. You could have also said that it's the same thing as the cosine of 150 divided by 2. So either answer works. Make sure, again, you're not writing down just these answers to write them down. Make sure that you understand where this is coming from, what is going on. I know I'm going through this kind of fast. Right here, I used my sum and difference identities. I found the cosine of 45 and the sine of 30 the cosine of 45 and the cosine of 30 minus the sine of 45 and the sine of 30. I multiplied them together and solved. So what? You can use either or. These answers, I will take both of them. Make sure you draw these triangles correct. I had a lot of people, especially in the first block, ask me, Miss D, I don't get it. This is positive, but it's in the third quadrant, so shouldn't these be negative? What's a negative divided by a negative? A positive. Make sure you're drawing these triangles out. It really does help. That's Brian Reinert's favorite part of the class, drawing these triangles. You should ask him about it. So, cosine of x, yes. No. Because that means that it's the cosine of x times the cosine of y minus the cosine, guys. Sine of x times the sine of y. Cosine of x, go to my x function. What's cosine? Negative 12 over 13. Cosine of y, go to my y function. What is it? Times negative 5 over 13. Minus sine of x, go to my x function. What is it? Well, it's 5 over 13. Sine of y, go to my y function, and it's negative 12 over 13. Multiply what I need to multiply. So I end up with negative 60, or oops, excuse me, positive 60 because they're both negatives, plus 60 over 169. Cosine of 2x. The answer is 119 over 169. The way I get it, I take my formula, 2 cosine squared. Why does it keep doing this to me? Thank you. I'm closing it. I'm opening it. What is wrong? Cosine of x minus 1. So that's the same thing as 2 times, and I go find my x function, find my cosine, negative 12 over 13 squared minus 1. The rest of the work is down here. Get my answer. Cosine of x over 2 tells me to go to my x angle. So I go up to my x angle and I plug it into the half angle formula, which tells me the square root of 1/2 times 1 plus cosine of x. Well, cosine of x is negative 12 over 13. I plug it into my formula. You will have to do this first. I do not want to see decimals. I want to see exact answers. If you tell me, I go to my math fraction button and it's not giving me anything, that's because it's a square root. It will not give you the fraction. You have to do the inside first. Tangent of 2x. That's the same thing as 2 tangent of x divided by 1 minus tangent squared of x. The square root of 26 over 26 for 15. And negative 120 over 119 for 16. You're just using formulas here, guys. I noticed that a lot of you on these ones are actually doing somewhat okay, right? We're all feeling a little bit more confident about these types of problems than the fill-in-the-blank ones, right? Where you actually have numbers. Good. Let's look at our identities. I know it was hard. I didn't give you that much time. So I see a 2A and I see an A. What did I tell you to do when you saw angles that weren't the same? Make them the same by what? What formulas do we have that make them the same? Double angles. Good job, Nathan. So I use my double angle identities. I put that in right here, times 1 over cosine squared of A. I just changed it to cosine squared of A to see what I would get, right? Change them all. The sine and cosine usually helps. Now, right here I used it it's kind of like, you know how you distribute multiplication, right? So I distributed this 1 over cosine squared of A to both terms. So when I multiply, I end up with 2 cosine squared of A divided by cosine squared of A minus 1 divided by cosine squared of A. These cancel, so I'm left with 2. And 1 divided by cosine squared of A is the same thing as secant squared of A. So, ta-da, I got it. So what? Yep, because it's 1 right here. Okay, for this one, what I did was the sum and difference identities. I said, well, that's the same thing as cosine of 3 theta times cosine of x minus sine of 3 theta times sine of x. And then I said, well, cosine of 3 theta, how do I find that? It's not on my tables.
3 theta.
3 theta, let's think about it. So if I go around a circle, how long does it take me? How many theta? 3 pi, excuse me. Thank you. 3 pi, excuse me. I am so sorry. It has been one of those days. 3 pi. I go around the circle, how many pi's have I gone? 2. So I have to go 3. So I should stop right here, right? So I stop right here. So that's the same thing as cosine of pi. Look up cosine of pi, and that is -1. Then I look up cosine of x, which, oh, guess what? I don't have an x because it's a variable. So keep it. Then I say minus, and I look up sine of 3 pi, which is the same as sine of pi. So it's 0 times sine of x. So you get negative cosine of x. Yes, -1. Because we have to go back. Here, let me go back and show you. So we have 3 pi, right? Here, cosine is 1. But that's 2 pi. We have to go 3 pi. Thank you. So now I solve this equation. I notice that when I have two things multiplied together and it's a sine and a cosine or a cosine and a cosine, and then I have the cosine and the sine or the sine and the sine, look it. I have a plus sign or a minus sign. I have either a cosine or a sine multiplied together. Has to be one of those two. And then I have the same thing, but they're flipped and the angles are the same. I look at my sum and my difference identities. This one says that that's the cosine of 3x minus x equals 0, which is the same thing as the cosine of 2x equaling 0. Two ways you can do this. You can, at this point, use your double angle identity and say that this is 2 cosine squared x equal or minus 1 equals 0. Or you could do what I did, which this is a restricted, you have to do this on the first one. But let's keep on going with this one because this one's easier to do it this way. I solve for cosine. So I get cosine of x equals root 2 over 2 plus or minus. I go look those up in my calculator and I should get 45, 135, 225, and 315. If you do not want to do that, if you just want to solve, you say, well, the cosine equals 0 at 90 degrees, 270 degrees, plus or minus 360k. Then you say, but I don't have x, I have 2x. You must divide everything by 2. Meaning, you will have 45, 135, then you'll have to add 180 times k. So you get 45 plus 180 is 225. 135 plus 180 is 315. Those are your answers. Yes. The reason I had to do that was because when I divided by 2, I wasn't able to get these two answers until I had that. But I stopped it there. You see how I didn't carry it out till the end? Because I did algebra. That's why I'm saying the easier way to do is use your half angle or your double angle identities and go down right here. Because you'll get all 4 answers. I got 5 minutes and I got 3 problems, right? Or 4 problems?
4.
I can't see your paper, so I don't know.
4.
Oh, this one.
So we did 20 already?
No, we haven't done.
We haven't done 20. So your answer is these ones down here. 45, 135, 225, 315. So now we're in terms of radians. So I see a 2x and I see an x. What should I use? If I see a 2x and I see an x and they're both in the same equation, what do I use? Nobody's going to answer. Everybody's going to get this one wrong in the test? What do we use? Which one? Not Pythagorean. That's if we see a squared. What if we see a 2? Double. So that's tangent of x times, and I substitute my double angle identity in. Equals 1. If you have step on the top and the bottom, I'm not going to get through this. 1 minus tangent squared of x. You have to multiply both sides. I then add my tangent squared x to the same side as I see it. I'm trying to have just one term, right? One trig term. I'm trying to isolate it. Equals 1. I divide by 3, and then I square root and rationalize. Number 21 is unrestricted domain, and 22 is unrestricted domain. What I did for this one, I saw that. What did I do? Oh, I saw that 2 cosine squared of x plus 2 sine squared of x is just 2 times cosine squared of x plus sine squared of x, correct? And now the whole thing's just 1, so that's where I get this. 2 times 1 is 2. Plus, and then I have the sine of 2x. So, that's the same thing as saying sine of 2x equals negative 1. Because it's unrestricted, the easiest thing to do is just find where it's negative 1, and that happens at 270 degrees. Then I divide everything I own by 2. X equals 135 plus or minus 180. Okay. Are you even writing this down, Nathan? Oh, taking it in? It seems fast, I know, and I only have 2 minutes. Number 22, I use my half angle identity right here to get it both in terms of cosine of x. I square both sides to get rid of my square root sign. I multiply by 2 to get rid of the 1/2. I add everything to one side and then factor, setting both of my factors equal to 0 and solving. Remember, I have to add and subtract my period, which in cosine is 2 pi. This last two I want to get through in this last minute. You're just setting them equal to 0. That's what I do. Set them equal to 0. Plug them in your calculator. Are they in degrees or radians? Make sure your mode is correct. Put your window, set your window as your minimum at 0 and your maximum at pi. For number 23, for 24, from negative pi is your min and pi is your max. Find each of these zeros. So your answers are 0.45, 2.0, huh? What? No, I'm telling you the window. I'm telling, just look at this guy right here. I don't care about anything else. So that's what I'm saying. I'm telling you. I will tell you on the test what to do. Same with this guy. These are your answers. Make sure you know how to do these on your calculator. If you do not, please come and see me at one of my, tomorrow I'm available after first block. After first block.
Okay, I'm back to this.
Why? No.
Wait, this doesn't have a
I have only